Okay, we're going to do differential equations applications. Now these questions are generally quite much longer to do, but once you get the setup, it's just a process to solve it. Now the words, we're doing example 16, which you can see there is in another city with the population P at time T years after a certain date. The population increases at a rate proportional to the population at that time. Construct and solve the appropriate differential equations and sketch the population graph. I couldn't write all that on my whiteboard, it wouldn't have fit. So we start with the most important fact, is that the population increases at a rate proportional to the population at the time. So the rate that the population increase is proportional to the population. So as a differential equation, we'll write that as dB dt equals Kp. K is bigger than 0 because our population is increasing. K is bigger than 0. If you get an application that's talking about a decreasing population or something is decreasing, you'll put a negative K. But this is increasing, so K is positive because it's increasing. We've got a positive rate of change. Okay, so this is really important. That's in your setup. If it's increasing, it's a positive K. If it's decreasing, it's a negative K. Okay, so increasing, positive K, because our population is increasing. So we need to solve this. So dP, Kp dt. Our variables don't match. So we're going to flip the P over P equals K dt. And we need to integrate both sides. So when we integrate that, we get ln P equals Kt plus C. So it's a straightforward integration for us. Then P will equal e to the Kt plus C. Now, we often write that as P equals AE to the Kt, where A equals e to the C, just our constant. So there we've got our graph. We've solved it. It's going to look like an exponential curve, an increasing exponential curve. And when P, when T is 0, this point where it cuts here will be A. Oops, that's better. So it's an exponential going up, positive curve. When T is 0, that makes this 0, that makes E goes to 1, so that's why it's A.